because nanoelectronics is something that I care about, transistors are the key element. And transistors are switches that help us really to enable nanoelectronics too. So a lot of the work that we're doing in the group focuses on novel types of transistors ideas. And so you really have to picture it as if you have an on-off switch that you're used to use for a long, long time to turn your light bulbs on and off. And now suddenly somebody tells you, well, this might have been a very good idea in the past, but what could you be doing in order to make a much better switch? And so thinking outside the box, coming up with creative ideas, that is what I'm challenging all my students to do all the time. And in particular, PhD students, in my mind, need to be creative when it comes to this point. Smartphones, have so many capabilities included because the electronics world is now so diverse that you can do many more things than you could do in the past. It's fair to say that any of the electronic gadgets that we are using now, and that is related to gaming to a very large extent, and large computer makers would acknowledge that their industry booms in particular because of that. The new home of the future that is also supposed to be having its own artificial intelligence, if you want. But all of these types of applications people are dreaming about, Star Wars, next generation, requires our nanoelectronics to become reality. I think it's actually at the heart of nanotechnology in general. For me, nanotechnology, not electronics only, starts with the material, but doesn't end there. It carries on to the devices part, ultimately to the systems and application part. Material in itself enables whatever device technology, whatever system level technology I'm interested in. Whatever makes my new device idea become reality will be used by us. And so this is the flexibility that we have in terms of materials. A new nanomaterial comes out, we are starting to explore this nanomaterial, we are learning something about its properties. Then we go back to this nanomaterials person and say, look, we have gained these insights. We think if you can tune the properties of a not yet existing material into this direction, then we could actually use this for a new type of device idea. And so this, for me, interdisciplinarity really is this feedback loop, the communication in both directions all the time. People are thinking about, hey, instead of just digging out new types of materials, I know by now that for a certain type of application, I would like to have this material X that doesn't exist in nature at all. So can I, as a smart materials person, then engineer this new nanomaterials with the right types of properties, right? And so that is another way of saying this feedback loop between the different disciplines is key for the future development. And so we have colleagues that are looking into all these various aspects and bringing in their piece of expertise. And if we can link these different activities together, then we have really a chance to make great things happen, hopefully. Different disciplines not just work together because it's nice to talk to a colleague in chemistry or whatever, but for the sake of new types of products, understanding the biological aspects in a better way and including them into electronics is very important. You're using very different approaches, different methodology. You have a very different background and you're analyzing the data in a very, very different way. And so if we can, in the future, make these different people talk to each other, being able to understand each other, which sounds very simple, but it's actually really as if you talk to somebody who speaks an entirely different language and you have no background at all, then we are moving in the right direction, I think, for what our society needs, namely bioelectronics applications.